China's brain chip beats Neuralink, but here is what nobody is talking about. Everybody thought Elon Musk's Neuralink would be the first company to take brain chips from experimental trials into real medical use. But something unexpected happened. China have taken the lead by approving the world's first brain implant for commercial medical use. This device is called NEO. But the most important part of the story is not that China defeated Elon Musk. The real lesson is how China reached patients first. So let's talk about this. First, what does this brain chip do? NEO was developed for people with severe paralysis caused by injuries to the upper spinal cord. Normally, when you decide to move your hand, your brain produces an electrical instruction. That instruction travels through your spinal cord, reaches your muscle, and tells your hand what to do. But what if there is a serious spinal cord injury? That could damage the communication pathway. So the brain is still sending or producing commands, but the command is not reaching the hand. What NEO did was to create a new digital route that bypasses the damaged pathway. This device is shaped like a coin containing about 8 electrodes, which is implanted in the skull, with the electrode positioned over the protective covering of the brain. When the patient imagines moving their hands, the electrode recognizes the related brain activity. A computer decodes what the brain is trying to communicate and sends the instruction to a soft robotic glove that is worn over the patient's hand. Here is how the algorithm actually works. The patient thinks about grasping, right? The implant then reads the patient's intention. The computer translates that information and a robotic glove performs the movement. With this, the patient is now able to perform basic activities like holding an object, eating, or drinking, meaning even a paralyzed patient could potentially work from home. Before you get too excited, so here's something we need to understand. NEO does not repair the damaged spinal cord. Instead, it creates a kind of digital bridge between the brain and the assistive device. The same technology could potentially support the clinical management of neurological conditions such as stroke survivors who could imagine moving their hands but have lost physical control of their arm or fingers. By connecting the movement with this robotic glove, the system could support rehabilitation exercises and help the patient practice useful movements repeatedly. For people living with amyotrophic lateral sclerosis, commonly called ALS, and other several conditions such as spinal muscular atrophy, muscular dystrophy, or locked-in syndrome, where the brain may remain active while the muscle gradually becomes weaker, a device like this could potentially allow patients to control a computer, select words, communicate or operate assistive equipment using their brain signals. However, it is important to note that NEO is not currently approved to treat all these conditions I have mentioned. There are likely applications of this technology in the future. And each condition would require, its clinical studies, safety evaluation, and regulatory approval. Now, back to the bone of contention. How is China NEO different from Neuralink?